All right, today we're going to talk all things sets. And again, I'm using the dot cam because, well, I still haven't figured out the fancy thing yet. But hopefully we'll have a few fancy ones mixed in so I can figure out how to use the technology. But I'm working from home today, so we're stuck with this one. Okay, so first of all, a relation is like a relationship. So you have a correspondence between two sets. So this is correspondence between two sets. A function, this is pretty much what our whole class is about this whole summer, everything. If at the end you're going to be like, oh, all we did was functions, all we did was input and output, and we inverse and isolated a lot, and we're kind of going to be doing the same thing a lot, but we're just going to do it with different functions. And so a function is kind of like if you think of two sets, like say we think of grades, right? And we have person A, person B, and person C. It could be that they all got different grades, a 60%, 70%, 80%. And probably the easiest thing you can do is graph them. So here's A, B, and C. And one of them, say, is at the 60 range, 70 range, and 80 range. And you might remember this from high school, but if you pass the vertical line test, it is a function because every input, so I don't want you to think of X's and Y's really. I want you to think of X's as being the input to the function. This is your output. So if I input your name in Canvas, the output should be a grade, okay? So that is a function. Now, this is also a one-to-one function because every X has a unique output. So now if it's a one-to-one function, it also passes the horizontal line test, meaning everything's unique, okay? So to be a one-to-one function has to pass a vertical line test and the horizontal because it has to be unique. Okay. All right. So say we have the same students. So student A, B, and C. And then over here, say student A gets an 80 and so does student B. And then C maybe gets a 90. All right. Well, okay. Again, let's graph it so we can get a visual because math is super visual. Always a good idea to graph. So say there's 80 and say 90 is up here. Okay. You're like, all right. Yes, it's a function because every input has one output. Okay. All right, so that's great. And you can see it passes the vertical line test. Now, is it a one-to-one function? Well, if you go sideways, notice it fails right there, okay? So this is not a one-to-one function because every input does not have a unique output. Every input has an output, it's just not unique, okay? All right, so, and in real life, can two people have the same grade? Yeah, so in my grade book, can I look up Anna's grade and, get an 80 and I don't know another name, Barbara and get an 80? Yeah, I can. Okay, that could totally happen. Okay. All right, so then let's look again. So say I have A, B, and C again. Okay, so those are my students. And say that I have an 80 and a 70 for her or him, whoever it is, 90, and C is 100. Okay, so if we look at this student again, Anna or whatever that person's name is, okay, if I graph it, so A, B, C, that's my input. Input always goes on your x-axis. Now, notice the output for Anna is a 70 and an 80. Okay, and then say, I don't know, the B person is up here at 90 and my C person's up here, maybe Carlos or something like that. Okay, now notice this is not even a function. So you can't even talk about it being one-to-one because you have to be a function first. So this thing is not even a function, not a function. Because if I look at my grade book at Anna and she has 2 grades in the class, that's a problem, okay? And that's where the word malfunction comes from. It's not working properly, right? This is not a function. Canvas would be messing up if I see 2 different grades for the same student, right? And so it's not even a function, okay? Now, if something is a function, we call the input the domain and we call the output the range. So the domain here is a finite set. Sometimes it's infinite. So my domain is here. And my range are these values, 60, 70, and 80. Here, my domain is still ABC, but here my range, my output is 80, 90. And it's not infinite. I only have 2 things there. This one, you wouldn't even do domain and range because it isn't even a thing, okay? So let's look at some finite situations, and then we could look at some infinite situations. Okay, so say I only have 3 data points. And this one, if you look at it, say I have 3 kids, and this is the month they were born and the date, month and date, month and date. So if I graph it, let's see, 1, 2, 3, 4, 5. So on the second month, we're up at 3. At the third month, we're up at 4. At the 5th month, we're kind of up here at 6. Notice this passes the vertical line test and the horizontal line test, but I only have finite points here. So my domain are just my inputs and my range, and those are what, months, and my output is the date that the kiddo was born. That's my output. And again, I only have 3, not infinite. Okay, so domain and range. I might have a situation like this where, say, I have, I don't know, like days that deliveries arrive or something in a month. So maybe, I don't know, maybe 3, another month, 3/21 or something like that. Okay. End of my set. All right, so if I graph this, and again, just sketching a graph, 2, 3, and 2, 4, right away, do you see how it fails the vertical line test? This guy is not even a function, so we don't even worry about domain and range, right? And don't memorize like if they have the same X or whatever. Think conceptually. This input gives that output, that input gives that output. That is not a function, okay? The same input cannot lead to the same output if you're dealing with a function. All right, let's look at another one. Again, we could do like delivery dates or something like that, whatever our input into our function is. Oops, I did that already. Let's change this to 3, and then let's make that a 3. All right, 3, 3. All right, so I'm going to graph this one. 2, 3 is right there. And then 3, 3, and then let's do like 3, 8, I guess. 3, 8 is up here. Again, fails, okay? So what would make it work? Okay, so let's see. If I had 2, 3, and say 3, 3, and then maybe, I don't know, let's try 4, 6. Let's play with that a little bit. So if I graph that, 2, 3, say is up here. 3, 3's up there, and then 4, 6. Okay, so that passes the vertical line test. So this is definitely a function. Fails the one-to-one, so it's not a one-to-one function, but it definitely would have domain, which would be what, 2, 3, and 4. Only 3 inputs are allowed. And my range would be my output. Now you won't put 3, 3, 6 because we don't repeat. So we just say 3 and 6, and that would be that. So sometimes you have a finite amount of points, like your function only is 3 or 4 points. That can happen. But a lot of times in this class, it's going to be infinite many things. So let's look at the square root function. And remember in my other video, I talked about this undoes area. So, the square root of 9 is a 3 by 3 square. The square root of 25 is a 5 by 5 square. It's undoing the area to give you a side length. That is the job of the function. All right, so there's infinite many input and infinite many output. All right, but I'm going to make an input output chart to kind of get a feel for this guy. Now, notice negative numbers. I need to think about these. You cannot square root a negative number. So that's going to be undefined. Every negative number is not going to be included in this. Now, there's infinite many input. I could go 0, I could shove in or sub in 0.5, I could sub in 1.28936, but I'm going to be strategic because I know there's infinite many points. I'm going to pick friendly numbers so that when I do the input and output, it's friendly. So 0 is friendly. Square root of 4 is friendly. Square root of 9 is friendly. 16 is friendly. 25, those are all friendly numbers. All right, square root of 0 is 0, 4 is 2, this is 3, this is 4, and this is 5. Okay, and I could have done 1 in there. I could do 1 if I want to. The square root of 1 is 1. I can do lots of things. All right, so let's graph this to get a feel for what's going on. My input is over here, so I could have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm not going to take time to label all those. Now, that's my input, and I have control over that, so I can choose friendly numbers. Output is what the function does. I don't have control over that. So let's see, I have a 0 there. Let's just go, 1, 2, 3, 4, 5. So there's my 5. Okay, so when my input is 0, my output is 0. When my input is 4, my output is 2. When my input is 9, my output is what, 3? When my input is 16, my output is that 4? It's hard to see sometimes on these 6. And so this guy, this function's not a straight line. Kind of reminds me like a turtle or a little mound or something, but it is slowly getting bigger as it goes off to infinity. Now, notice there are infinite many points in this. I could have plugged in or subbed in any number I chose to, but I chose friendly ones, but the ugly ones are in there. I just didn't pick them. Okay. All right. So now, does it pass the vertical line test? Yes. So this is definitely a function. Does it pass the horizontal line test? Yes. So this is a one-to-one function. Okay, that's even more special. All right, so then what else do we want to talk about? Okay, so then we tend to talk about domain and range. Now, this is where it's not finite countable points. This is infinite. Okay, so with domain, you want to think left to right like you read a book. So if I start here and go this direction. Now, sometimes people mess this up. So I think for domain, it's a good idea to cover this up and be like, oh, what do I hit first and where do I go? And zero's included. So we use a bracket when it's included and it is going off to positive infinity. Okay. Range, good idea. And when we do interval notation, this is like one of the only times you ever do interval notation for the range, for the Y value. Pretty much all the time, we always do interval notation for things dealing with the input because we're like, oh, what input makes this happen? So range is about the only time I'm like 99.9% sure, range is about it for doing interval notation with a Y. It is very rare. All right, this Y is included, so that's also 0 because that 0.00. And notice this is going off to infinity. Now, extremely slowly, right? I mean, it's slowly going to go up over time, but very, very slowly. But it's still going off to positive infinity. And again, if you like to put a positive there, you can to emphasize it, but you don't need to. All right, so that is domain and range. Okay, the other thing we talk about is increasing and decreasing. And this is kind of like a roller coaster. So if you think of, we got a little roller coaster here. If I put like a card on it, do you see how it's increasing here? So from this